Okay, good afternoon, everyone. My name is Gaurav, and the next presentation is about the how to implement the specific extension based on the existing Experimenter framework in ODL. So this presentation is out of our learning, whatever learning we had, and I want to thank most of the people who helped me over the IRC in the forum, especially Michael Rihag. So out of those inputs and whatever we explored around, this is what we have come up with, and it will contain most of the bits and parts where we can start writing our own experimenter message using the existing framework. It's not like the framework is already there in the plugin and the ODL, and using those, we can start writing our own new vendor-specific messages. Okay, so messages can be either the RPCs or it can be augmentation to the match actions. So with respect to this presentation, mostly we will be covering only the experimenter part of it, but the idea is same. So if you see how the experimenter messages are covered, the idea is same, only the classes and the methods changes. Okay, so let's start with that. Okay, so the agenda is long, but we'll try to cover most of it on the way. So we'll start with introduction. What is experimenter message, and how does OpenFlow spec explains that, and then we'll go on with the actual explanation from the OpenFlow spec with the actual headers and all those stuffs, with the actual syntax of the experimenter message. So as I said, we'll be only covering the experimenter message part of it, but yeah, the idea is same and the flow is same for all the other conversions like match, extension, the action and extension and all those things. Okay, we'll go through the list also. What is the list which can be used for the vendor conversions, or which can be extended for the vendor conversions. Okay, so after the experimenter message, which is mostly the structures which are covered as from the OpenFlow spec, we'll go on to the extensibility support, the existing experimenter framework. A part of it, how does it support the experimenter message and all those vendor extensions. Okay. With that, we'll cover the workflow also. Workflow as in, there will be two things, the RPCs and the notifications. So the RPCs is mainly about the way we start from our vendor-specific bundle and we send the message down to the switch. Okay, so that flow will be covered in this part of the presentation, ODL controller to the device. So how we send the message, the vendor-specific formatted message to the device. And the other part, which is the notification part, will be the when the device sends the notification or the RPC reply part of it to the controller, and how this will be handled by our bundle. Then we'll be covering the core context of this of writing the experimenter message, which is the registration and the registration of the deserializer and serializers. So this is what is as per the lithium plugin. So where the general serializers and deserializers are already existing, and you have to write your specific serializers and deserializers and pass it on using a key to the deserializers and convert those. Similar to this conversion at the OpenFlow Java level. Okay, so before going into the OpenFlow Java plugin and all, so the structure is we have our MDSAL module or our applications where we write our vendor-specific bundle. Then we pass it on to the plugin. The plugin will have a converters there, and those will convert from MDSAL models, which we have written, the vendor-specific model, to the OpenFlow Java understandable models. Those models then convert, those are converted, those are serialized or deserialized based on whether we are sending down to the switch or we are expecting a reply. And those things are then converted into the bits and sent to the netty and finally to the switch or back from the switch. Okay, so just understand that application, then the plugin, and then the Java part of it. So plugin deals with the converters, and the Java part deals with the serialization and deserialization part of it. Okay, so similar to the OpenFlow Java part, where we do the serialization and deserialization. we do the plugin conversion also. So plugin converters need also to be registered. So we'll see what are the classes which provide the utility method to convert the converters. Okay, and after running through this part of the presentation, we'll also have a sample message which shows the actual implementation, which will have a sample vendor written classes. Not exactly, but the idea will be very clear with that. So Manohar will be covering the sample experimenter message with the details of registering, deregistering, and with the plugin converters, and also with the YANG of it when you write a new YANG, new vendor specific YANG. Okay, so what is experimenter? So OpenFlow spec, as per the spec, experimenters are the way where vendors can define their own extensions or own messages. Okay, so these messages these messages are not only the RPCs or the notifications. This can be anything. You can augment the actions, the matches, and all those stuff, or it can be entirely new message itself, or it can be an RPC, or it can be a notification. Okay, so experimenter messages provide a standard way in which we convert. So from here onwards, I'll mostly be talking about the experimenter message, not the other parts, the action, the match. But yeah, they are very well supported in the ODL, and that can be either converted from, can be utilized for our vendor extensions. Okay, so OpenDaylight provides a well-established experimenter framework as such in the Lithium plugin also, which is the latest plugin. And we just have to enhance that, or we have to use those APIs and the implementation to reach the end result, which is our own writing our own messages or extending our own vendor-specific messages. Okay, so this is just a motivational quote. So it says the experimenter is the least arrogant method of gaining knowledge. Though after the presentation, we might agree to that. Okay. Okay, so this is as per the OpenFlow spec. OpenFlow spec, the structure is as per the OpenFlow spec, which says, this header is for the experimenter extensions. So it says, as we can see, it has a base header, which is the OpenFlow header, which will have the version, whether it is 1.0 or 1.3, and other TLVs. Okay, and then it has the experimenter ID. So this is a 32-bit value, which is uniquely defined. Either you have to uniquely identify it so that your extension should not be conflicting with your other peers extensions. Okay, so once we have the experimenter ID, extra data as in we can have a EXP type which carries the experimenter defined data. This is the core where we defined our data. So let's take an example where we are writing the symmetric message. Symmetric message is when you send down and you expect a reply. So when you are writing a symmetric message, what we expect that our message should go down, and for that we'll be getting the reply. So how there the EXP type can be used. So let's say I'm giving valid ID number 1 to my EXP type when my message goes down. Okay. For the similar transaction ID, I expect a message 2 as a reply for that RPC. So there I can use EXP type as message 1 and message 2 for my RPC going down and RPC coming back, or the notification coming back. So that is where I can use my EXP type. This is nothing but an experimenter defined. Just an example I told that a number thing can be used for up and down message. This can be used for any of our defined purpose. Okay. So as I told, this is not only one part. Experimenter message is not only the one part. So what we'll be dealing today with this symmetric experimenter message. So these are the stuff which are supported by the experimenter framework as such in the ODL. So meter is to be supported. Other things are already supported. There is some glitches in the multi-part part of it, but other three is very well supported. So we'll be dealing with the symmetric experimenter message. Okay, so this support is covered by the existing framework extensibility support, and this, as per the directory structure and code analysis, this framework sits for now in the OpenFlow plugin part of it, which provides the points where we can do a registry and deregistry. So the plugin part, if we want to see an example for that, it will be one of those nicira-extensions where we can go and find the extension of OpenFlow, extension of the experimenter part of it. Okay. Okay, so actually this is the gist of the presentation. Okay, we are too early on that, but yeah, this will give an idea when we move forward to the other slides. Okay, so what all we need when we are starting with our own vendor message? Okay, how should we start? Let's say I'm very new. I know there is experimenter support present in the OpenDaylight, but how should I start with that? How should I start writing my own vendor specific? Starting point is to start the vendor specific YAML and the config YAML. Okay, so the configuration can be in two ways, the config subsystem and blueprint. So that's another topic where the ways of injecting a dependency, we can do either by the blueprint or by the config subsystem. Okay, so for now, let's say we have defined our message. We have written a YAML, we have our new message with some strings, some data, some RPCs, some notifications. But my YAML will be requiring dependencies from the other classes. Like I will be needing a notification service, data broker service to initialize the RPCs, to get the RPCs handle services. Okay, so those are defined in the config YAML. So we start by our own vendor specific YAML and then the config YAML. Okay, okay, so we are done with the YAML. We have written the YAML. Now what is the next step? Okay, so our experimenter message should not collide or should not have the same unique experimenter. So same ID, experimenter ID, it should be a unique enough for our vendor specification or our vendor implementation. So we need to have unique experimenter ID for the implementation. Then what? We are done with the two steps. Now we have to write our own serializer. We have a sample application where we'll show from scratch what all classes need to be extended and interfaces need to be implemented, and what are the methods we'll be using for serializers and de-serializers. For now, we are done with the YAML. We have a unique experimenter ID. Now what? We write our own specific serializers and de-serializers and register it to the experimenter framework. Okay. Similarly, plugin converters also need to be registered to the experimenter framework. Now I have a converters. I have both the serializers and de-serializers. Okay. Now this RPCs and notification classes, there are specific RPCs and notification classes which will be used for sending and receiving the messages. So this RPC service, which is already provided by the experimenter framework, will be used to send the experimenter's message down. We'll see in the sample application. So that RPC service will use and send the message down. There is a notification class. We'll be listening to that and taking action on the message received from the device. Okay. So as we went through the flow, this is the crux of it. So it says there are two steps where I can start writing my own vendor specific. So I need to convert MD-SAL models to the Java models, OF Java models, okay, which is done by the plugin converters. Once those are done, I need to convert those Java model into the bytecodes, into my wire protocol, into my netty understandable code. Okay, those are done by the Java serializers and the de-serializers. Let's see two up and down flow for both the ways, sending the RPCs and listening for the notification. So okay, so what I have to do for my vendor specific message to augment to understandable to the existing framework. I augment it. I augment to the existing MD-SAL model. It can be an entirely new model. Okay, and that contains my vendor specific message. Then the OF plugin looks for the suitable converters, which converts the MD-SAL models to the Java models. Once those are converted, it's given to the Java to serialize those code that are serialized into the bytecodes and sent down to the netty. And this is how your experimenter message goes down to the wire. So this is the RPC way. Similarly, the other way. So device sends an experimenter message or a notification to the Java. Then Java looks for the suitable. See, at starting we have written our specific serializers and deserializers, and there will be a generic serializers and deserializers, which will map to your specific thing based on your registration. So we have registered it. Now this Java will look up for my specific deserializers, deserializes it, and give it to the plugin. Plugin now looks up for the converter, since we have also registered the converters of the plugin. And finally, it is given to our vendor specific bundle, where we can process the message. So this is the to and fro way. So this will be mostly, we can relate to this when we see the sample app. So sample app will actually have the code, the snippets, where we can relate how these things are used. Okay, so this is the framework. Now we are getting more into the code part. Okay, what all classes we can use for registering. We know we have to write a YANG, we have to convert one model to another, then we have to convert to bytes and send down. But what are the classes we'll be using? Okay, so switch connection provider. This is the existing class which has methods for deserializers and serializers. Okay, so this is more like a generic class I was talking about. So I have to write my specific class. Specific class will register this to the these methods using a key. Okay, so what is a key now? Okay, so if you see, this OpenFlow switch connection provider is nothing but this instance of this class is used to register my experimenter message serializer. Okay, so this experimenter is very generic. It's very specific here. Okay, so we can do register my match extension serializers based on the match action. So as I told, we'll be covering mostly the experimenter message part of it. So based on what implementation I am extending for the vendor extension, these methods will change, but all are there for this, present for this providers. So we use this register as per our implementation for experimenter. We use register experimenter message serializer. Serializer key, I'll come back to this. There is a separate table for that, how you prepare a key for this serialization. Okay, this impl is nothing but our own serializer which vendor has written. So you register your serializer here. Similar to this class provider, the Deserializers. Again, this experimenter is more specific to this implementation. It can be match actions. And we do we prepare a key. Key again, I'll come back to these keys again. We have a separate table also for that. Okay, and then again, this is our own specific deserializers. So we are done with the registration. What if we forget this step? Okay, so we'll meet these exceptions, the illegal argument exception, because our specific serializers and deserializers are not registered with the generic code, general experimenter messages. Okay, so this is the graphical view of what we are talking till now. So this is our custom bundle. This is our new vendor specific or vendor message bundle, where we write YANG, where we write all the config YANGs, and where the classes are there for registering our thing, registering our specifications. Okay, so what you do, you write your specific serializer, deserializer here, in this case deserializer, and you register it. How do you register? Message codec key. Okay, so message codec key will take these many things. So this has the message version based on the UF 1.3 or 1.0. The value is the experimenter ID we were talking about, and the class I'll come back. We have a separate table for that, what all class. Based on our implementation, we have to pass the class. Like in our case, we are dealing with the experimenter, so we'll pass this experimenter class. Similarly, for match and action, the class will differ. We have a table for this, which is the class. Then, once you are prepared with this, when you are done with the key, you register it using this provider. Okay, so there is something called enhanced thing. Not explored much, but as the name suggests, these has a separate values, but I have not explored much. Okay, so this is the key. This is again the way you prepare a key, but these are some extra values. We need to look for this. What are the extra values? So you have prepared a key. You have written your specific deserializer. Register it using this utility. Okay, similar to this, the serialization process. Very similar to this. You prepare a key, message version, but if you notice, the class names are different. This uses the codec key, and this uses the type key. Okay, so message type is EXP type we were talking about, the type, the extra experimenter data. And similar, other things are very similar here. So using the same class, we register it. And this is our impl, which is nothing but our coming from the custom bundle. Okay, so this is what I was saying, the key part. So based on this extension, so for now we are dealing with the experimenter message. Based on this, the key, the syntax for preparing the key, the utility class used will differ. So we have vendor message. So in the starting, we had what all is supported by the experimenter framework. So these are all the things we are supported. So it says meter band, but the implementation is not complete. So you can do vendor message. Okay, so this is OpenFlow 1 version, 1.0 version. Okay, so whatever, so name can be changed. The vendor message in 1.0 is nothing but an experimenter message in 1.3. So similar to that, action is supported for both 0 and 1, 0 and 3. Similarly, starts and all those things. So this says the plugin, this says the OpenFlow spec version 1.0 or 1.3. This is the type, actual type which we are going for the extension. And this is the way we prepare a registration key based on the type. And these are the utility classes which we'll be using for this. It's a similar table. The way you deserialize, the similar way we serialize it. And this table is again helpful. In our case, we are using message type and message type key. So these are the again classes. This is the version and registration key and the utility classes. Okay, so we are done with the Java part. So that's a lower layer. We are done with the serializers and deserializers of the Java part. Now, we will go through the plugin things. So plugin also, there will be converters to and from. So from MD-style models to Java and from Java to MD-style models. So this is the class. So this is all out of the learnings. So this is the class which will be used for the registration of the converters. So this is how we register. So this is an object, this is an instance of this class, and you do register message converter key. Key is again the way we form, the way we are using, the way we decide our implementation to be. The key is depending on that. Then this is the specific converter. The converter can be to or from Java. So the two registration are there. So this class is common and this API is common. Register message converter in both the registration, but only the key and the converter we write differs. So the to and the from part, with the key and the converter it differs. Okay, so this was with the classes with some of the implementation methods and with the key, how we form the key, and part of it how we write a YANG, and these things with an example will be covered with the sample experimenter message where Manohar will walk through the YANG and the conversion part of both the Java and the plugin. And finally, what our classes are used and what is the service used to send down the message and what is the listener used for receiving the message. So I hand it over to Manohar.
Yeah, thank you, Gaurav. Yeah, thanks, Gaurav. Hope this is audible. All right. So yeah, while we go, this is mostly the last portion of the presentation where we wanted this to be more as a handover book. I mean, yes, we had a lot of theory on what has to be done, but if you were to follow those 1 to 10 steps, what is it you have to do is exactly what we have in the next few slides. Before I delve into that, maybe I'll clarify one point, and then also look at a show hands on how many really understand OpenFlow and whether there's been a need to really extend that, and also talk a little bit about that, and then go to this portion which will be a few slides only. Gaurav talked about yes, as he told, you need to extend this experimental implementation in the OpenFlow Java plugin and your own bundle where you do the needed particular action which we understand best, because we have a need for extension and we do that. But plugin, he mentioned something called a lithium plugin. Not sure how many on the floor are really very heavily using OpenFlow Java, but to generally talk about that, yes, we are on the boron release, and why are we really talking about lithium? what has happened, a little bit of a rewind of history on plugin as a project. I mean, if you're connected there, Helium time is when we had the plugin is one of the core bundles of the overall ODL architecture. I mean, right after OpenFlow Java, we need this layer to bring in this, model conversion from the MDSAL model onto the OpenFlow Java model, and that's a typical workflow also we take to, implement the Experimenter implementation as well. Lithium time frame, we had a parallel implementation, and as of Boron around June last third or fourth week, Lithium plugin design has become the default design. So now onwards, we can say the current plugin design. Having said that, there's a history to that, and we still have retained the Helium plugin design in the stable Boron and the master. So if you have a need and you still want to fall back to whatever you had tested during the Lithium time, the code is still retained. But having said that, we definitely want to move to the current Lithium design, which is kind of, Lithium is the name, but we can just start calling it as more of the current plugin design. And that's become a default also as of stable Boron, and so continues on the master for Carbon. That's a little bit of history there, just to demystify the naming across releases. So right, so stable Boron and Carbon, the current master, what we have is the latest plugin design. And this presentation is completely geared in the context of the current plugin design, as in the name Lithium plugin. Maybe from now onwards we'll stop using the Lithium plugin as a name, but it's kind of geared towards the current plugin design. Having said that, I just want a quick small help. Any show of hands on how many have really been hands-on on OpenFlow as a protocol on the floor? Okay, right. So I do see about 10% of the guys. So maybe to give a perspective on what exactly we're trying to achieve here, and what problem are we solving here. A little bit of theory part now that we actually have some time also, before we don't want to hold you guys before lunch for a long time. But having said that, yes, we still have 20 minutes of solid time. Typically, I mean, OpenFlow has been the protocol which was, originated again by the founders of SDN as one of the prominent protocol to communicate between the controller and the DP and data plane. Having said that, OpenFlow by itself is not SDN. It's one of the recommended way of communicating from control plane to the data plane. Having said that, we have all of other, southbound options, be it a netconf or, SNMP and whatnot. So all those are very well, made available in OpenDaylight as an architecture as well. But more particularly, as we embark on this SDN journey and go more by the typical recommendation of how the journey started, and if you are of such a vendor group or a community interest or whatever it is, academic interest, if you happen to be associated with more and more of OpenFlow as a protocol, right? I mean, it's defined by ONF, Open Networking Foundation, as a standard body. And they have versions of OpenFlow spec. Started off from 1.0, we have 1.3. 1.3 was a leap for progress on the way you can program the data plane, because we fundamentally came out of the single table to multi-table pipeline, and that enabled so much of envisioning of features and whatnot, and we were able to bring in so many NSF, as we call it, in the context of ODL architecture, network service function that can be implemented in the ODL architecture, leverages pipeline. I mean, remember, in the morning security group, we had Ashwin who showed this nice pipeline of diagram. So all that is possible only from and above OpenFlow 1.3. So OpenFlow 1.0 was just a single table, like a FIB, maybe forwarding information base, as you typically had in the previous IP context. But come OpenFlow 1.3 is when we had this multiple table pipeline, and that's what is being explored. Right. So typically, I mean, definitely we all have this background of IP packet handling. So typically, when you get a packet in, the fundamental, three-step liner I would like to do is match on all the header content I have, and realize that it is, matching on some particular criteria, and take some action on that. On the data plane, you will always be on a hurry to, quickly understand what has to be done, do the L2 switching, set it on a particular port. Right. So in that journey, so OpenFlow spec, by the way, is very well defined. I mean, I would definitely encourage folks who have not really had the opportunity to look into OpenFlow spec till now, maybe look at the spec at least at a very high level, preferably OpenFlow 1.3 and higher. We have 1.4, 1.5, 1.6, I guess is also kind of made available. 1.4 also had a lot of enhancements in general. But yeah, coming back to this context, in the data plane, I'm always in a hurry. You fast, I mean, FDIO is one name people are taking around, parallel implementation of the data plane implementation, and which kind of, more of a parallel to the OVS as a project. So fast data plane and, .io, input output as they call it, right? You're always in the data plane, you want to be in this quick mode of transporting the packet, from the ingress point to the egress point. In that mode, right, I mean, given the OpenFlow spec, I can do a match field by about, spec defines about 39 match fields. and I can take so many actions which are defined by the spec. And I can communicate with the device between the controller and the DPN with so many messaging what the spec supports. So there can be a need to me as a vendor or a community or a campus guy or whatever it is where I want to extend from this spec. Generally, from any spec definition part, we always have this placeholder to bring in the VSA, as we used to call it, vendor specific attribute or vendor specific extensions are there, and that's one important vertical or concept in OpenFlow as well. They have done a very good job where every nut and bolt of OpenFlow can be expanded, extended based on the vendor extension. So if you land in that situation where you find a limitation in maybe the OpenFlow match criteria, action criteria, or let's say the extreme case, the messaging itself. They have a beautiful, handshake of the way OpenFlow handshake happens, and you take this particular, DPN onto the controller and whatnot. I really don't want to go into much into that. But generally, the perspective I'm trying to really add here is you can extend any part of OpenFlow spec, right from extreme case, altogether new message, to maybe a match or an action. So when I as a vendor or a community guy or as a campus guy land in that situation, right? I mean, spec supports that. I mean, the spec defines on what are the structures you need to plug into to bring in the plug-in word in general. I don't want to use it in multiple contexts, but in general, if you want to attach your extension and then realize your feature, spec supports it. So OpenDaylight as an architecture, being an architecture which provides a very strong OpenFlow southbound communication, provides a very strong support for that extension as well. So that's what we're trying to do here. So spec supports it, and OpenDaylight as an architecture supports it. So what will be my typical journey to implement an extension, in the OpenDaylight architecture is what we're trying to cover here, just to give that perspective more as we have a little, more time while we go along. So typically, a match field or an action is a very small snippet of operation you do in a lot more handling of the OpenFlow you typically do. While handling my own experimenter message is the most extreme step and most involved step, which is exactly the reason why we are covering that in more detail, because once you get a handle on this, you typically touch the complete vertical flow right from your particular sample app to the plugin to the OpenFlow Java, and we know which are all the portions I have to touch upon. And so that gives you the extreme exposure to how you really have to do. With this knowledge, it will be a lot more easier to try to extend an OpenFlow match or an action criteria. So, which we're not covering here, but it should be more simpler with this perspective. Last but not the least, very important point. You can ask me that, yes, as a vendor, I'm now implementing all my, secret sauce, so to say, on my match field and my action and my message. So the code is also pretty glued. If you look at the OpenFlow plugin code hierarchy, there is something called as an extension as a directory where I can drop my code and need not be contributed to the community. So while you leverage the framework provided by the OpenDaylight architecture to implement the needed extension, that code can be a secret sauce residing in your own code structure and whatnot, and you can achieve that intended in-house extension on the OpenFlow spec. Again, this story is only half complete from the control plane, right? I mean, end of the day, to really leverage and realize that feature on the on the field, you would definitely need an equal support from the DPN data plane also. So which means that typically whatever I define as a vendor of the extra match field, extended match field, extended action or extended message has to be acknowledged by the DPN as well. So it typically goes hand in hand. You would again go back and maybe on the OVS data plane open virtual switch, you would want to similarly implement support for all these extended match field, extended action or extended message. So that has to be done as well. So that completes your story of you can completely take over a parallel extra or extend the OpenFlow criteria from the control plane to the data plane. Only then the story is complete, and we can really leverage some unique use case which you have in mind, and that can be done. So that's more like a vertical solution which we have to implement, not just in control plane but also the data plane. On that note, it's a lot of text from now, and so small that even I'm not able to read on the screen there. So, please take this as last 4 or 5 slides as more of a takeaway handbook. While you are in a situation, or let's say you want to try out implementing some of these extensions, this can be very handy to you to know what all you have to do. And in that context, try it out and reach out to us, and we'll be more than happy. I mean, typically, as Gaurav told, once we set out implementing this in the current plugin context, we had to interact with a lot of the plugin designers and OpenFlow Java designers, understand. So this is an outcome of that. So, maybe we had to spend X amount of time, hopefully, after this presentation, and with this presentation being available to you, the intention is you should be able to spend, 0.2, like 20% of the time, maybe 10% of the time, ideally, less than 5% maybe. So that's the effort of this presentation, so to say. So the kind of complete cycle involved in understanding what it takes to implement, and the amount of knowledge we generally, having been in the situation of implementing this, we have gone through. We wanted to optimize on the time and make available a presentation where similarly, if somebody else has to try it out, it should be a lot more lesser effort. And having said that, it's a very vibrant community. A lot of thanks to Michael Rehak, who really helped in understanding a lot of the nitty-gritty here. So with that, I'll really come back to the slides so that we move along towards the lunchtime and take this to the closure. So as Gaurav talked about, we had to register the layers of OpenFlow plugin, OpenFlow Java, and finally define the message what I have in mind. So that's exactly what is happening here. And augmenting extension registry. So we'll have to plug in our implementation or register our implementation in the registry we have. And we have to do that at the plugin and the Java layer. And finally define the message which of interest to us. That's exactly what is happening here in 3 bullets. The first portion we have is the plugin layer registration. And the second layer is, the more of the OpenFlow Java layer registration. So typically you'll see this word called OF Java, OF for OpenFlow and Java for the southbound codec layer. That's a last stop and netty layer, and then you're on the wire transporting the packet to the data plane. And finally define the message of interest, and that's what is happening here. As I said, a lot of this code will not be available. You don't have to do it in the actual plugin folder. So let's say whenever you have to do a code sync, it will not damage your code. It will be in a proprietary bundle, so to say, and which, of course, being a secret sauce, you don't have to give it to the community, and then it will not break your code. So that's the simplicity of it, right? As I start implementing the extension on the OpenFlow spec in the ODL architecture, and you do it the way it is recommended, you will not have any code breakages whenever you do a sync from the upstream community code onto your internal code base. Registration. So a little more in detail. As I said, it's more of specific details so that you can take it as a handout. And what we see here is again registration of at the plugin layer and the OpenFlow Java layer. So first is typically this is really garbled, but the slide deck is pretty good. So you'll be able to make sense out of that once you go through the slide deck. So register message converter key to OpenFlow Java. This to OpenFlow from OpenFlow is something like, take it like this. When from the plugin level, we'll have to convert the empty SAL model onto the OpenFlow Java model. So to OpenFlow Java is you're going southbound. You're on the journey to send out the packet or data to the DPN, out of the controller to the DPN. From Java is when you have got the message from the DPN data plane and you want to handle that and then give it northbound to the particular NSF, network service function, to handle that. So that's the direction, so to say, and that will give you a little bit of more contextual information on what am I really coding here. To OpenFlow Java, you're going southbound, converting to OpenFlow Java, on the wire it goes out. From OpenFlow Java, I got a message from the DPN and I'm handling that and giving it northbound to the specific implementation so that I can make sense out of that. So that's the indicator there. All right, so serializer and de-serializer. So yeah, this is a little interesting. I'll just read this out for you. What you see here is something called byte out buffer. So those are the little bits and bytes going on the wire, and yeah, and the particular object which is being converted. So what typically happens is at the OpenFlow Java layer, while the coding encoding is happening, and we are on the way to send out this message on the wire, I get a handle to the out buffer, which will be generically encoded by the OpenFlow Java layer, and it will send on the wire. So you get a reference to that out buffer here, and we understand on what exactly I need to encode depending on the structure what is being defined. Maybe yes, I can spend a little bit of time to re-explain, emphasize on some points here. So as Gaurav mentioned in detail, we have the version and we have the experimenter ID. That's a 4-byte vendor specific data, which you can typically stamp it by standardization body. And EXP type. Let's say, it's not like I have only a requirement to code only one experimenter type message. I need to implement, multiple types of it. So you can differentiate them by having something called the EXP type. So when you get a message, as we had one of the detailed slide there, it's more like a reference book. The experimenter message is of type 4 as per the OpenFlow Java spec. So whenever I get a message of type 4, what it means is I look up this registry as an OpenFlow Java level and call the particular vendor specific implementation for that. So that's what typically happens. And yeah, so while experimenter message is of type 4, I can more do a fine-grained identification of the individual message by something called the EXP type, which is what is sitting here. Okay. Yeah, so serialization, de-serialization is more of a codec operation. where so out buffer dot write data or write byte is what you're doing when you're sending data on the wire, and when I get the response from the OVS, the switch back to the controller, is when I have got the byte stream and I need to convert. So what you have got in hand is now a byte buff. So the byte stream is available to you, and it's like, you know, 10s and 20s and 30s of bytes. I can only make sense depending on what I have defined those bytes to be, depending on what type and, you know, typical semantics which you define in a TLV format. So that is understood by the vendor given the context of, so you're in charge of those bytes in understanding coding and encoding, decoding. So when I get this handle to this byte buff, now I can, you know, inflate that onto an object which is understood by the architecture. So I can return back, an object which is now, you know, relatable in the rest of the architecture. So take those byte buff, understand them bit and byte, move along, inflate that onto an object, and give that to the plugin, which will in turn propagate that to the higher level architecture. So that's kind of what is happening here at the OpenFlow Java level. All right. Plugin converters. So yeah, so typically again similar operation happens at the plugin layer also. We do something called, you know, converter and translator. When I'm in the path of sending the message out of the control plane to the data plane, I'm converting it onto the OpenFlow Java plane. It's like to Java, to OpenFlow Java, send it on the wire. When you get the response back from the switch, it's like, you know, from Java, translator, and then give it back to the application which you have in hand. So that's the flow which you're trying to, you know, highlight here. The flow of this slide is something like, you know, we are opening it up layer by layer, more from the bottommost module to the topmost module. So when I get an experimenter message from the DPN, the data plane node, OVS, to the control plane, I first need to decode the data, then give it to inflate an object, give it to plugin. Plugin will translate the data to the empty cell object and give it to the particular, you know, my implementation, which will finally make that sense of the and achieve the use case which we have in mind. So that's the layer by layer we're going. It's kind of, you know, bottom-up approach, which is the way we have shown here. But yeah, having said that, it's more of a vertical implementation which you anyway have to do. So this will be more like a handout slides, which will be handy to really, you know, go along once you're in the situation of coding your vendor extensions. All right, so the same story which is happening in the plugin level here. So typically you would want an API, something like send DXP message, which is what is happening here. So typical flow will be the module will do send DXP message, experimenter message, that will go convert to Java, and converting it to Java layer, and then finally it will go on the wire. If I get the data back, it will be, you know, convert from Java, and now you have to on experimenter message from device. By dev we mean device here. So I got back the notification from the device. OpenFlow Java layer has done its job of inflating those many bytes onto an object, and I have that object in hand now, and convert that to a more understandable object at the higher level, which is my particular, you know, vendor implementation. So that's a reverse inflation which is happening here. All right, so finally if we were to conclude and take away, I mean, as we are trying to say, it's a very contextual requirement we have, and in general we thought it will be a good effort to summarize this effort and have some ready-made, ready reckoner kind of a content. Whenever anybody is in a situation when you want to extend or, you know, realize any extension in the OpenFlow spec, ODL supports at big time. That's one thing which we really want to advertise here. So OpenDaylight architecture supports every extension of the OpenFlow spec big time. And if you were to do that, and this is, you know, kind of your next reference will be this document maybe, so that you can run through this, understand on how we really go about implementing that and achieve your use case. But again, as we already told, to have this end-to-end realization of this, you need to have it not just in the control plane, that's one part of the story, you will have to have it on the data plane as well, which means that if you have OVS as a switch, that again has, you know, mechanism to realize this on the switch, only then the story is complete, and you can realize your end-to-end solution you have in mind. So just to complete this, OpenFlow spec defines Experimenter as a way of allowing vendor-defined extensions, which we talked about. Vendor message needs a specific serializer, de-serializer to serialize, de-serialize at the OpenFlow Java layer. And similarly, plugin converters and converter and translator needed to and from the OpenFlow Java layer. So typically you'll be, you know, hand-holding and coding on these two layers, and then on I have my specific module to do the required handling on this experimenter data. Finally, experimenter messages are sent using SAL experimenter message service, while notifications are by the listeners we do. So that's the overall content in a nutshell. It's a very contextual presentation. Sorry if you made a, you know, it little more involved on the code side and all that. So the perspective really here is, if you have a use case in mind when you have to extend the OpenFlow spec, ODL supports that, and this will be your ready reckoner to go through that step and, you know, realize that. That's really the context here, very, very, you know, contextual to the situation we have to be in. But I believe Yes, OpenFlow spec is also evolving, and maybe most likely you might be in a situation where you want to extend the spec, and this can be a very handy tool or the presentation to go through and start realizing your use case there. That's pretty much what we had. Any questions on the floor? We'll be more than happy to take because we still have about 5 minutes before we can break out for lunch. Yeah, please go.
So thank you for explaining this. I think understanding the OpenFlow headers, in order to add any new extension is very, very tough. So for example, take the case of so basically SourceNet. So the first slide that so Gaurav showed, it has a structure. So I actually wanted to learn how that will look for a SourceNet in the case of basically a match and action pair.
Yeah.
So are there some tutorials available? Because I understand I can use the plugin.
Got it.
But
Okay.
let's say I want to write C library basically.
Right.
So so using so basically the BCN files, and I want to extend them. So I want to know how can I understand how
Sure.
the structure would look like if I implement a SourceNet.
Okay. So most likely, you wouldn't want a message here, as I understand. You wouldn't want to, really go out in adding a new experimenter message per se.
Yes.
Maybe it's an experimenter action or match is what you want to do.
Yes.
So the job is more simpler here, I would say. Maybe you can also add to that. You can take this mic maybe while I spread. Right. So this is typically like the given the hierarchy of ODL architecture, we have the OpenFlow Java layer, which will typically get a flow mod or group mod you want to send, right? In that flow, it takes care of encoding, the bulk of the data for us. So it will come to a point where I have an experimenter, match field. So typically, yes, we can also look at the spec where they also allow attaching a structure to the flow mod and the match field, and that will have an experimenter type. And the moment I hit upon that experimenter type, we'll have a registry, right? We'll have a registry to look up and say where exactly I have to branch out now to actually encode that match or the decode that particular response data. So typically in this flow you want to program the match and the action. So it's more of the encoding action and programming it on the data plane. So the typical flow will be the ways and means of encoding a flow mod message very much in ODL architecture. The ways and means of encoding this on 39 odd match and the various actions very much in place. But the moment I hit upon this experimenter match field, it will look up a registry, which is what we are trying to register here. And it will be for that specific match field, it will come to your implementation part of the code, and you'll get a handle on that out buffer at the OpenFlow Java layer, so to say. And you are in control of those many bits and bytes. And you can plug your data. And similarly, on the data plane, when the particular switch will embark on an experimenter match field, it will be on its control, a vendor-defined implementation. It will make sense out of that. So that's where, as Gaurav told, we are going to stamp the vendor signature here, so to say, which is a 4-byte data. So which means that only the particular vendor's implementation of the switch alone can make sense out of that. And a good generic handling to do will be, if I don't understand this experimenter ID, I'll give back an OFPT error by telling unknown experimenter ID for a non-vendor implementation, so to say. So for match and action is pretty much more simpler, where you just have to hook on to this particular place of experimenter match and action. A message is where it is a lot more involved, where you're in complete control of, apart from the OpenFlow header, literally we define the entire structure on how it has to look like and all that. That's where we took this as a complex example to run through. But having said that, yes, we can enhance it maybe offline to also add some more slide deck to talk about how exactly we can do it for match and action, and circulate to the folks in ODL forum, and they can make it available through the link we have. And we're more than happy to help you on any query you would have. But yes, that's more simpler job to do, and definitely we can enhance the PPT to cover that as well.
Thanks a lot.
Something? Yeah, thank you. Any other questions on the floor? Yeah, that leaves us with 1 minute before lunch. I think we can break for lunch, unless anybody has further questions. Thank you. Enjoy your lunch, and we'll connect back in the second half.